a PhD candidate at the University of Nottingham. Murtaza is an architect by degree and has received his training from IIT, Roorkee, India, and HSLU, Switzerland. The floor is yours, Murtaza, if you can share your PowerPoint, please.
Thanks a lot, John. Thanks for the introduction. While I share my presentation, I would like to echo with what Professor Tim mentioned about the impact of the transmission is more potent in indoor space compared to outdoor spaces, because indoor space has more poor air quality, air ventilation, and that could lead to higher contamination. That's an established fact across many studies in transmission of the pandemic. So good morning to all my colleagues in the UK, and good afternoon to all my Chinese fellows and colleagues in China. I'm Murtaza Mohammadi from Nottingham University, and I am investigating, my research is all about understanding the transmission of pollutants between indoor and outdoor environment, and how urban design or various factors can affect that. So briefly, this is going to be the outline of the presentation. I'll talk about a bit of the background, the gaps in the current study, how my objectives would provide some insights, what were the methods I used, and we can conclude with results and conclusion. Air pollution. Well, it's the topic of discussion, gaining increasing importance due to, and it's no doubt it is, because there's higher anthropogenic activities and you have more poorer air qualities than previous years, and so it is impacting human health, and it is a hazard for many occupants or many people in entire population in cities. And amongst all pollution effects or pollution spaces, indoor air quality is most important, as I feel more people spend a significant quantity indoors, and the pandemic has also accentuated that fact, transitioning work environment into indoor spaces. So in an indoor environment, the figure on the right, so you have an indoor space. It could be exposed to its own sources, including human activities or including cleaning, smoking, or mechanical equipments. At the same time, it is also exposed to transmission of outdoor pollutants, ambient ones, into the indoor spaces. That could be happening through windows or cracks in doors and window frames, or in the building fabric. There could be through the pores in the building fabric, and there are other mechanism of transmission. So an indoor space is always exposed to multiple factors of pollution transmission. My research showed that in a typical urban canyon, you have various factors affecting how pollutants are dispersed, including prevailing wind direction, solar radiation, the flow separation or flow recirculation inside the canyon, local canyon elements, including trees, pedestrian cars, and so forth, and the mode of ventilation in the buildings themselves, including natural, mechanical, or infiltration modes. So all of these factors influence how the indoor space interacts with the outdoor space. And depending on the extent of how each factor is, for instance, a higher wind speed above the canyon could lead to a decoupled airflow, and you have a more less dispersion of pollutant inside the canyon. Sufficient to say that the indoor spaces will be more polluted. So my study revealed, the literature has revealed, that currently we use deterministic models or mathematical tools to predict how people inside indoor spaces would be exposed to outdoor pollutants. So essentially there is a lack of finer spatio-temporal resolution of investigation, assessing how building fabrics would affect this transmission. Additionally, many of CFD studies or other numerical investigations either specifically look at only outdoor dispersion or only look at indoor ventilation, and there are very few combined studies which could give us a better clue of how indoor and outdoor spaces are interacting with each other. So that is going to be the main objective, or has been the main objective of my study so far, wherein I'm investigating transmission characteristics between the two environments and the role of other environmental factors, including the urban layout, the temperature in the canyon, the solar radiation, wind speeds, and local elements, and so forth. And knowing this, one can then effectively plan intervention strategies to limit this contamination. So I followed a three-step method to investigate this. The first was to develop a numerical model of a typical street canyon and see how dispersion occurs. And then we put in the internal indoor spaces with polluting sources. And then you do parametric assessment of different elements to assess which factor is most prominent in transmission. So these are some of the results from few ventilation strategies adopted in a typical canyon. In the base case, street pollutants are accumulated in the leeward facing canyon wall, which is widely been explored, and the results have all suggested this. However, opening windows in those buildings could alter the pollutant concentration inside the canyon as well as indoor space as well. So, for instance, in cases 3, 1, and 2, where the building is ventilated from either the windward side for the windward building, or it's the other face, the building is facing in the other direction, of course the pollutant transmission will be less. But in case 2, it's widely seen that it's been seen that natural ventilation or cross flow of air helps prevent outdoor pollutant to move inside your indoor space, and at the same time it can dilute the pollutants inside the canyon. The worst case, however, was case 4. It's a one where single ventilation is predominant for both the buildings, and they are ventilated from the canyon side. So essentially all the emitted pollutants inside the canyon is accumulated indoors. And case 5, however, is the best case because both buildings are cross ventilated, ensuring least transmission. So I decided to explore case 4 further and investigate how indoor source in particular would impact other internal environments. So for instance, now imagine instead of cars outside, the polluting room, the pollution source is the room itself. You can imagine this as a person coughing, or could be another indoor activity. And in these cases, however, there's a difference in transmission characteristics. So the downstream building affects the lower floors on the same side, whereas the pollutant source located on the upstream building affects the floors above it. Yesterday, there were a couple of speakers speaking about discussing the findings on transmission of COVID virus, and a reference was made to SARS pandemic earlier in Hong Kong. So the findings are quite similar in line with them. However, I go further in exploring how other factors could also impact this transmission. So for instance, if you introduce cross ventilation in a typical canyon, then you are sure to impact the local environment, the public environment, or the road level or in the canyon, but you limit the transmission of virus from, I should say pollutants released at one internal space to be transmitted to other indoor spaces. However, the common space, the outdoors, is significantly impacted even in this form of ventilation. So there should be, or intervention strategies should be designed to limit this transmission or improve the outdoor quality within the canyon. So typically cross ventilation prevents outdoor infiltration. However, it can accumulate outdoor pollution in side ventilation. In terms of indoor contamination, cross ventilation mode can accumulate pollutants slightly inside side flats, but not in the central located flats. However, for side ventilation, central units can lead to accumulation in the central region of the canyon, whereas side units spread the pollutants throughout the canyon. So a graphical image should explain this clearer. So imagine a polluting source which is located on top of a building on a downstream building. So those emission from that source can contaminate significantly all the units located nearly in the center of the canyon, especially ones located just below it. However, if this polluting units is located on the upstream building at the far corner, then although the transmission occurs inside into the canyon and other regions, the concentration is much less. So depending on the pathogen or the pollutant we are dealing, if a strategy should be designed to limit that kind of pollutant. So for instance, in a pandemic when you have a pathogen or virus, so transmission of a pathogen is also dependent on the time it takes for that pollutant to enter from leave a unit and enter another unit. So is that time will the virus or pathogen become inactive during that phase? So in that sense, the transmission route in the case of a side located unit is quite long. That could prevent, although the virus could be transmitted, then the impact would be less, as its potency has decreased significantly until then. So in the next steps I plan to undertake is investigate other building building design or neighborhood design, and see how that can affect the transmission nature, and also introduce additional indoor space and indoor layout, and see how that impacts the transmission in indoor spaces. Thank you. I hope you got a sense of the impact of this research, and if you have any suggestion or you'd like to collaborate, do drop me an email. I'll be happy to take up discussions.
Thank you, Murtaza, for that talk. I think